students, welcome back. I'm Rinkesh sir. Today we'll start with exercise 10.3 of chapter number 3, that is straight line. In the last video we had studied some concepts and basics. Now let's start with exercise. Reduce the following equations into slope-intercept form and find their slopes. Now we know that the slope-intercept form, right, like slope intercept form is y equal to mx plus c. Okay, where m is the slope. So now first x plus 7y equal to 0. So 7y is equal to minus x. Y is equal to minus 1 by 7x. Or I can write it down as y is equal to minus 1 by 7x plus c, where I can take slope m is equal to minus 1 by 7, and this is the form of slope intercept. Here, let's see the second one. 6x plus 3y minus 5 equal to 0. That will be 3y equal to minus 6x plus 5. Y is minus 6 by 3x plus 5 by 3. So now again it is equal to y equal to mx plus c. Okay, this is the slope intercept form, where the slope is m equal to minus 6 by 3. Clear? The third one, it's y equal to 0. Okay, so now I can clearly write it as y equal to 0x plus 0. The slope intercept form, where m, the slope m is equal to 0. Clear? So this was about question number 1. Just note it down. Now let's move to the next. Next question is, reduce the following equation into intercept form and find their intercepts on the axis. So we know that the intercept form is equal to x by a plus y by b equal to 1, where a is the x-intercept and b is the y-intercept. Let's see the first one. 3x plus 2y minus 12 equal to 0. It will be 3x plus 2y equal to 12. Now we want here 1. So what I will do, divide both the side by 12. That implies 3x by 12 plus 2y by 12, that is equal to 12 by 12. So 3 ones are 2 6 are and 1. So it will be x 4x minus 3y equal to 6. I want here 1. So divide both the side by 6. 4x by 6 minus 3y by 6 equal to 6 by 6. So see, 2 are 2 3. x upon 3 by 2 minus y by 2. See, I have taken these 2 on this other side. Clear? This became by 2 minus or plus y upon minus 2 equal to 1. So this is the slope intercept form where x-intercept is equal to 3 by 2, y-intercept equal to minus 2. Clear? So this was about the second question. Now let's see the third one. Third, it is given that 3y plus 2 is equal to 0. 3y plus 2 equal to 0. Clear? So now see, divided by minus 2. So 3y by minus 2 equal to minus 2 by minus 2. So that will be equal to 1. So here I can write down 0x plus y upon minus 2 by 3 equal to 1. As 0x, because this will be a horizontal line and that will never intersect x-axis. Clear? So this was about question number 2. Just note it down. Now let's move to the next one. Question number 3. Reduce the following equations into normal form. Find the perpendicular distance from the origin and angle between perpendicular and the positive x-axis. Now we know that the normal form is x cos omega plus y sine omega is equal to p. Clear? So we need to find out cos omega and y omega. Sorry, sine omega. Clear? Now, to find out cos omega and sine omega, let's take this method. See, if the equation of line is ax plus by plus c equal to 0, then the perpendicular distance p will be equal to modulus of c upon under root of a square plus b square. Okay, cos omega will be equal to minus a upon under root of a square plus b square if c is greater than 0, or a upon under root of a square plus b square if c is less than 0. And sine omega, that will be equal to minus b upon under root of a square plus b square if c is greater than 0, and plus b upon under root of a square plus b square if c is less than 0. Clear? Just note down this formula first. Okay? Now see, if I am using this first, x minus root 3y plus 8 equal to 0. So here the coefficient of x, that is 1, coefficient of b, that is minus root 3, and the constant term c is equal to 8, that is greater than 0. Clear? So first, perpendicular distance modulus of c, that is 8 upon under root of a square plus b square minus root 3 square 3, 8 by root 4, that will be equal to 8 by 2 by root 4, that is 2. Sine omega, that will be equal to b minus b, right? So minus of minus root 3 upon root of 1 plus 3, that is equal to root 3 by 2. Now say cos is negative, sine is positive. In second quadrant, remember it's in second quadrant. So I can write down omega is equal to 120 degree or 2 pi by 3. Clear? So you need to understand in which quadrant it is. If sine was negative, cos was positive, it will be fourth quadrant. Right? So it will be minus 60 degree or minus pi by 3. Clear? So the normal form that will be equal to sorry the perpendicular distance of the perpendicular distance from the origin is equal to 4. The next is angle between perpendicular distance and angle between perpendicular distance and positive axis. Angle between perpendicular and positive x-axis, that is equal to 4. Clear? So this was about question number 3. So just note it down. This is the first part of question 3. Second, y minus 2 equal to 0. So here clear cut, there is no x coefficient of x, there is no x term, so coefficient of x is equal to 0. B coefficient of y 1 and C minus 2, that is less than 0. Okay, so the perpendicular distance modulus of C upon under root of a square plus b square. So modulus of minus 2 plus 2 under root of a square, that is 0, b square, that is 1, so that will be equal to 2. Cos omega, that will be equal to a upon under root of a square plus b square, a is 0, so it will be 0. And sine omega, that is equal to b, that is 1 upon under root of a square plus b square, that is 1. The value of cos is 0 and sine is 1 at pi by 2. Clear cut, here we can see that it's y equal to 2. Right, this equation is y equal to 2. So this will be a horizontal line. Normal form x cos pi by 2 plus y sine pi by 2 equal to p, that is the perpendicular distance 2. Clear? The perpendicular distance from the origin second of question number 3. Now let's see the third one. X minus y equal to 4. So I can rearrange x minus y minus 4 equal to 0. The coefficient of x 1, b that is minus 1 and c that is minus 4 less than 0. Clear? So now perpendicular distance, that is modulus of c, that is modulus of minus 4 upon under root of a square, that is 1 square 1 plus b square, that is minus 1 square 1. So that will be equal to 2 by root 2 and that will be equal to root 2. Clear? Now cos omega as c is less than 0, it's minus 1. So minus a upon under root of a square plus b square, that is root 2. Sine omega, that is minus b, so minus of minus, the normal form x cos 3 pi by 4 plus y sine 3 pi by 4, that is equal to, sorry, not 1. What is the perpendicular distance? Root 2. Okay. So the perpendicular distance uh, from origin, that is equal to root 2, and the angle made between perpendicular distance and positive x-axis, that is equal to 3 pi by 4. Clear? So this was about question number 3. So just note it down. Now let's move to the next question. Find the distance of a point minus 1, 1 from the line 12 into x plus c equal to 5 into y minus 2. So first, let's reduce. Now see, first let me give the equation. Distance between point x1, y1 and line ax plus by plus c equal to 0. That d will be equal to modulus of ax1 plus by1 plus c upon under root of a square plus b square. Okay, so now it's c. First note down this formula. Now see the equation is given 12 into x plus 6 5 into y minus 2. So 12x plus 12 into 6, that is 72, equal to 5y minus 5 into 2, that is 10. Now our first aim is to convert it into form of ax plus by plus c equal to 0. So 12x minus 5y, when 5y goes on this side, minus 5y, plus 72 plus 10, that is equal to 0. Okay, so 12x minus 5y plus 82 equal to 0. Now what is here a? 12. What is here b? That is minus 5. What is c? 82. So now what is the formula for distance? The distance, and see here the point A is minus 1 and 1. So I will take x1 equal to minus 1 and y equal to 1. The formula for distance, that will be equal to A, that is 12, x1, that is minus 1, b, that is minus 5, y1, that is 1, c, that is 82 modulus upon under root of 12 square plus minus 1. So this will be equal to minus 12 minus 5 plus 82 upon 12 square, that is 144, plus 25. So that will be equal to 65 upon root 169. So that will be 65 upon 30. So the distance is 65 by 30. Remember, this distance is the perpendicular distance of the point from the last. Note it down. Okay, students, so that's it for today. Thank you.